Hi, my name's Alan Smith, and in this webcast, we're going to look at the object detection functionality in the Azure Custom Vision service. In the previous webcasts, we've looked at image classification, and this is where we take an image and classify it according to a tag. This image will be classified as a cat. This image will also be classified as a cat. This image will be classified as a dog, and we've got another dog here. And the image is just being classified with one tag. With object detection, we have an image that may contain multiple items. And the model will detect these items, and for each item detected, it will give us the tag for the item and a bounding box around the item. When working with object detection, it will take a lot longer to create these datasets, as we'll have to identify and tag all of the items within the images. So in order to create some training and test data, I'm going to Google for Harry, Ron and Hermione. I'll select images, and you can see that we've got a lot of thumbnail images. When I'm working with image classification, I often save the search page in Google, which contains all of these images. However, when working with object detection, I find that these images are too low resolution. However, if we open a new tab, you can see we get an image in a much higher resolution, which will make it much easier for tagging the faces in these images. So I'm going to hold down the Control key and click on images that are going to be suitable for generating the training data to train the model and the test data to verify the accuracy of this model. I'm probably going to need about 40 or 50 images in total, which is quite a small quantity when working with custom vision solutions. But it will allow me to tag all of the images in a reasonable amount of time. So I'm making sure that I'm selecting just photos of Harry, Ron and Hermione. And I'm selecting photos where all three characters are pretty much facing the camera. So you can see that I've got a large number of tabs open in the browser. If I press Ctrl Tab on the keyboard, I can navigate to the first tab. I can then save the image. I'll create a folder called Hogwarts and save the image there. I can press Ctrl Tab and then save the next image. I'm going to repeat that process for all of the open tabs that I've got in the browser to save down the images. I'll pause the recording whilst I do this. So now I've saved all the images. We need to clean the data and remove any unsuitable images. I'm going to navigate to the Hogwarts folder in Windows Explorer. I'm going to add the width property, and you can see that some of the images are quite low resolution, and these will be quite challenging to tag, so I'll delete these images. So I'm going to run through quite quickly, delete any images which appear to be duplicated, and also delete any images that are hand-drawn rather than photographs. And that's hopefully going to give us a much cleaner data set. So we've got 46 images in total. I'm going to create a new folder called Train and a new folder called Test. I'm going to pick 16 of the images, pretty much at random. And I'll move these into the Test folder. The other 30 images I'll move into the Train folder. So we've got 16 test images for verifying the model, and 30 images for training the model. Although it's a very small data set for training custom vision models, it will hopefully be suitable for a quick test of object detection using the Azure Custom Vision service. So I'm going to browse to the Azure portal and locate the Custom Vision service that I'm using for these webcasts. You can see that this is running on the free pricing tier. So it's free to use, but it does have fairly limited capacity in terms of the number of projects and transactions that I can run. In the Quick Start page, there's a link to the Custom Vision portal. And here I can create a new project. I'll name the project Harry, Ron or Hermione. For the resource, I'll select Custom Vision Webcasts. I'll specify that the project type is going to be object detection, and we'll be using the general domain. So let's create this project. The first thing we need to do is to add the images that we'll be using for training. So I'll navigate to the train folder, select all of the images, and click on Upload. And you can see that 30 images have been uploaded successfully. They're all in the untagged category, and I've got no tagged images. When working with image classification, it was easy to upload and tag large amounts of images. However, when working with object detection, we have to specify whereabouts the object is going to appear within the image. So I'm going to have to tag all of these images manually, which is why I'm using 30 and not 300 images. So let's take the first image. I'm going to draw a box around Harry's face and define the tag as Harry. I'll do the same for Ron and for Hermione. So the first image has now been tagged. I can click the arrow to move to the next image and repeat the tagging process. There's Hermione, there's Harry, and there's Ron. And on to the next image, and so on. So tagging images can be a time-consuming and tedious process. So I've speeded up the clip so you don't have to sit through watching me do it in real time. And you can see that we've now got 15 instances for each tag, so I should be able to train the model. So let's select Quick Training and click on Train. So the training process is complete. It took about 7 minutes to train this model. And you can see we've got the statistics for the accuracy of the model. As I was using a very small number of images, the statistics here won't be very accurate, so I won't pay too much attention to those. But what we can do is run a quick test on this model. And in order to test the model, I'm going to navigate to the test folder and select one of the images. You can see here that it's correctly identified Harry, Hermione and Ron. And we can see the tag names and percentage probabilities for these predictions. Let's take another image. Here it's identified Ron successfully, but it's predicting that Ginny Weasley is Hermione with an 87% probability. Harry is predicted successfully, as well as Hermione. In this image, it's making correct predictions for all 3 characters. In this one, it's predicting Ron as Hermione. We can modify the threshold of the predictions that will be displayed. If I lower the threshold value, we can see that more objects are predicted. Here it's predicting that this hippogriff is Hermione, and it's predicting that Hogwarts is wrong, though these predictions do have very low probabilities. So you can see that the Azure Custom Vision service provides a quick and easy way of being able to train models for object detection. Creating a dataset and tagging images is significantly more time-consuming, so that's why I've used quite a small dataset. But with larger datasets, you will be able to generate much more accurate models. My name's Alan Smith, and I work as a developer, trainer, mentor and evangelist. I'm an Azure MVP, and I speak at many international conferences. I specialise in delivering classroom and on-site training in the Microsoft Azure and AI technologies. I also deliver remote training and mentoring. I host seminars and workshops for companies. I've authored a number of Pluralsight courses, and I also speak at conferences. If you're interested in any of the above, feel free to contact me on cloudcast.net@gmail.com.